Hi everyone and welcome to today's Chemistry Daily Booster. This is number 13 in our Paper 2 series and it is advanced information listed for both the higher and foundation chemistry. What we're going to be doing is starting off our work on C6, so that final chemistry module. And to start off with, we're going to look at fertilizers. So first thing, we need to know what plants actually need to grow. And we refer to these as the essential elements, of which there are three: nitrogen, phosphorus and potassium. So in order to grow, all plants need nitrogen, phosphorus and potassium. If they don't get enough of those, what we will see are certain symptoms in the plant that just tell us what that plant is lacking. We refer to those as the mineral deficiency symptoms. So a lack of nitrogen means it's going to have yellow leaves and it doesn't grow very well. Lack of phosphorus, poor root growth and discoloured leaves, and a lack of potassium, discoloured leaves and poor fruit growth. Obviously, if we've identified that the crops we're trying to grow have a lack of one of these particular minerals, we need to do something to replace it. And what we do is use a fertilizer. So quite simply, fertilizers replace the elements that plants use as they grow. So when plants grow, they're going to be taking these minerals from the soil and therefore depleting it. We've got to be able to replace those in order to keep growing plants on that same area year after year. Key thing about those fertilizers that we're going to use, they've got to be soluble in water because they need to be able to dissolve so that the roots of the plant can absorb it. In terms of the form that these different minerals take, then what we find is they don't just occur as nitrogen, phosphorus and just potassium as an atom. Instead, we're looking at certain ions. So nitrogen occurs as the nitrate ions or ammonium ions, phosphorus as phosphate ions and potassium as potassium ions. So what we can actually see here is this is tying in the work from our first chemistry paper where we had a look at the compound ions, we had a look to see how we write formulas of ionic compounds. It brings that together here. In terms of the type of fertilizer that we use in commercial instances, we use what we refer to as an NPK fertilizer. N for nitrogen, P for phosphorus, K for potassium. So these fertilizers contain all three essential elements, and depending on the fertilizer you select, they will be in different ratios. How do we actually make these fertilizers then? Well, for the most part, we're going to be making ammonia, and to do that, we use the Harbour process. So the Harbour process requires nitrogen and hydrogen as the raw materials. Nitrogen comes from fractional distillation of liquefied air, hydrogen from reacting natural gas with steam. So nitrogen from the air, hydrogen is going to come from our natural gas and steam. What we're going to do is carry out a reversible reaction then, and you can see it's a reversible reaction because of our little reversible reaction sign. And what we're going to have, nitrogen plus hydrogen, remember N2 plus H2, is going to then make NH3. To balance it, 3 in front of the hydrogen, 2 in front of the ammonia. You can obviously balance in the exam, or you could just memorize that one because it does come up time and again. So just learning it with the balancing might be easier if you really struggle with balancing itself. Once we've made that ammonia, then we're going to need to put it into a compound in order to obviously give us more than just that single nitrogen input for our plants. So in our fertilizer factory, we'll combine it with other chemicals, and we will get these kind of 4 key fertilizer chemicals, if you like: ammonium nitrate, ammonium sulfate, ammonium phosphate, and potassium nitrate. So depending on which ones of these are present, obviously will tell us what elements we are then returning to the soil. So when we have a little look, we can see, obviously, if we're looking for the fertilizer to select with the highest amount of, let's go with potassium in this case, then we would have to pick potassium nitrate because it's the only one with potassium with the K there. If we wanted the highest amount of nitrogen, then what we'd have to do is work out which has the most nitrogen atoms in its formula. So if we look at ammonium nitrate, we've got 2. In the ammonium sulfate, 2 nitrogen. In the ammonium phosphate, we have 3 nitrogens. So the best one to use would be ammonium phosphate because it has the most nitrogen atoms. How do we make these fertilizers then? Well, it's a simple neutralization reaction between an acid and an alkali, because acid plus alkali makes salt and water. Don't forget, we could pull on that knowledge in order to name those salts or to suggest the name of an acid and an alkali used to make this fertilizer. Could be asked in either way. If we're looking for the name of obviously the acid and the alkali, then first of all you've got to look at the salt name. The second word will tell you which acid it is, because if it's chloride, it's hydrochloric sulfate, sulfuric nitrate, nitric phosphate, phosphoric acid. So the acid bit, dead straightforward. For the alkali, write down the name of the metal, so the bit in green on our screen at the moment, and then stick the word hydroxide after it. Works in all cases, absolutely fine. Now, if we're going the other way, obviously, write down the name of the metal first of all to give us the first word of our salt, look at the acid, and remember our little table at the bottom there to get the second word. This could be another one of these areas that we get to pull on the idea of titration, because when we're doing this in a lab, we use titration to achieve this. So we've already had a booster on titration. Here's a recap. Fill the burette with acid, volumetric pipette transfers the 25 centimeters cubed of the alkali to the conical flask, add a few drops of your single indicator, record the start volume from the burette, add the acid while swirling the flask until the indicator changes colour, record the end volume from the burette. Repeat until you obtain those concordant titers within 0.1 centimeters cubed of each other, and then what we'll be doing is adding activated charcoal. That just basically binds our phenolphthalein, which is going to be the indicator we're using in this case, filter the solution to remove the activated charcoal, and then you can evaporate it off in order to leave just the fertilizer crystals. If we're looking at how we make chemicals in industry, different to what we do in our school lab, we have two processes available, batch and continuous. If we want to make large amounts of bulk chemicals, like our ammonia, this would be made by continuous process. If we wanted to make a small amount of a specialty chemical, like pharmaceutical drugs, they would be made through the batch process. So batch, small amounts of specialty chemicals, continuous, large amounts of our bulk chemicals. Here's a little table that just summarises some of the kind of key points about batch and continuous process. So if you have a little look, our key features are down the left hand side there. So rate of production, relative cost of equipment, number of workers needed, shutdown periods, and the ease of automating the process. And by that we mean, can we let computers do a chunk of it for us, not humans? So if we look at batch process first of all, it's a low rate of production, but the equipment is cheap. However, we need lots of workers. We've got to shut down the whole facility frequently in order to clean the equipment and swap over different chemicals, etc. And therefore it's not easy to automate. Continuous process, however, has a high rate of production because we make large quantities of those chemicals. The equipment cost is high because a lot of it is automated. Because of that, however, then we need fewer workers and we don't really need to shut down the machinery. It's really just going almost 24 hours a day, 7 days a week. If there are bits you'd like to look at in more detail, obviously we do have the C6 playlist on the channel that you can look at. Don't forget you have hopefully revision guides that you can use, and it's always worth looking at some of those past exam papers before you set foot in the exam hall as well, to get a feel for the kind of questions that come up here. Then of course don't forget to join us again tomorrow for our next Daily Booster.